All right. So we talked about strings and loops and all that stuff. So now we're going to go over some of the solutions for the little assignment. So for this first one, for all the string ones, there's multiple ways to do all of these things, right? You can use the substring commands, you can use the gsub commands, you can kind of do some sort of combination of those. I did all of mine with gsub, but you can do substring, that's totally okay. So for example, this is our vector. Let's call this names. It looks like this. Maybe we'll do it like this so you can see it better. All right, so we got our names. So this first one is saying to only keep the first names. So one way you can do this, the way I like would originally think of this, the most basic way, is just to use a substring. So just start on the first character and go until you see a space. Right, this would be a pretty simple way to do this. So if I wanted to do substring, I would just say, I want to substring names. I want to go from the very first character until I find a space. So the position of the first space is always going to be given by regular expression, space, and then names. So just as an example, five, 7, 5, 7, 7. So if I run this, we have Alex, Jeremy, Nate, Jordan, and Julius. Now there's still that extra space there because it's inclusive. So it will find the position of the space and include the space. So if I wanted to remove that space, I could just do -1. Now give me the first names. Now, if you wanted to do this with gsub instead, which is the solution I came up with for the homework here, what I did was I told R to look for this any sort of element or the first space followed by anything and then anything continued. So if I do gsub \s names, I want to replace this s with nothing, I'll get rid of all the spaces. But instead of getting rid of all the spaces, I want to get rid of the spaces and then anything that comes after spaces. So if I do s dot, I'm now getting Alex. I delete the J because that's the space and the next character, any next character. So the plus is looking for the spaces, any next character, and then continually any next character. So essentially it's going to find this space and it's going to say, this is the next character. This is also any next character, also any next character, also any next character. So it'll just give me the first names. Now, if you remember, the way we deleted just the middle names was we put an extra space here. So this will say delete this space, any next character, any next character, any next character, any next character, until you find another space. So it's almost like a sandwich in a way. So if I run this line, it'll just get rid of the middle names. Now, notice how it didn't delete the space for Julius Randall because there was only one space, any next character, and then there's not a second space. So it couldn't delete that space out of Julius Randall. Are there any questions about this one?
Read it one more time, please.
Just to go over it one more time?
Yes, thank you.
Okay. So originally, if I'm looking for, do you want me to go over the gsub solution or the substring solution? Both. Okay. So for substring, if I'm looking to just take the first name. Okay. If I'm looking just to take the first name, I'll tell it what vector I want to substring. I'll say, give me the first character. So that's the beginning of the first name. And then go until I find a space. So regular expression is going to tell you the position of the first space it finds. Now, when you do substring, it's going to tell you the first space inclusive. So if I don't do this -1, it will give me Alex space, Jeremy space, Nate space, and so on. So if I do -1, I remove that one extra position. I remove that one extra space. So that's the substring solution. So for G sub, I'm telling R to look for a space followed by literally anything, and then continually anything. So I'm asking it to find a space and then anything that comes after it, and then as many times as I find anything. So it's a little bit like really general to say find anything. Like for example, if instead of doing this, I put alpha, in this case, it would also still work, I think, because this is looking for alphanumeric characters. So it would delete a space followed by any alphanumeric character on and on and on until it finds not an alphanumeric character. In this case, this space would actually be not an alphanumeric character. So it actually deleted space alphanumeric, space alphanumeric. It actually did it twice. So I just put period here because it was shorter. Okay. So that's how you get rid of the first names. So now let's think about how would we keep just the last names? So as a substring command, right? Let's think about how we might do this. So instead of going from 1 until I find a space, I probably want, if I'm trying to find this guy, maybe I want to go from a space until the last character. So just go with me for a second. So let's just see what happens if I just say find a space and then go to the end of the string. The way you say end of the string is nchar. If I do this, not quite, right? Because it's giving me the first space. So something you can do is if you wanted to do multiple substrings, you could say this is like sub1. And then maybe I wanted to get rid of that leading space. In order to do that, you could do trim WS, trim white space. Oops. I don't know if I discussed this yesterday, but that will delete leading and trailing white space. So now if we look at sub1, it looks like this. So now this next one, again, you're gonna have to be a little clever. You'll kind of do the same thing, but instead of names, you'll have sub1, sub1. So now I have Cardazi, Barbara, Moon, Elam, and Randall. And then again, I would have to trim white space. And this could be sub2. So notice how when I called this one, I'm asking for the space of sub1. Now, Julius Randall didn't have a middle name, so it's actually going to return -1. So thankfully, R will just recognize -1 as the first position. So sub2 should give us the answer. Oops. So that would be like a substring solution for this. But again, the G sub solution, as I have here, is I'm saying find an alphanumeric character as many alphanumeric characters in a row, and then find a space and replace this with nothing. So let's start with just the alphanumeric characters. If I do this, I'm getting rid of everything, right? So obviously, no, this is not the solution. If I add a plus here, this is still not going to be the solution because it's just going to ask for alphanumeric characters in a row, which these are names, so they're always going to be alphanumeric characters in a row. For example, if my name was like A2 Lex or something like this, it would keep the 2, right? but what I'm saying with this is find a string of alphanumeric characters, or just alpha characters, I guess, not numeric, and then stop once you find a space. So including the space. So what it's going to do is it's going to say, okay, this is a string of alphanumeric characters, and then I found a space. I'm going to delete that. Here's a string of alphanumeric characters and a space, delete that. Here's a string of alphanumeric characters, but there's no space. So I'm going to keep that. That's what this solution is doing. So this is just keeping the last word. Are there any questions on this solution? Okay.
You'd want to, like, if you had last name and then if it was dirty data, you'd probably want to trim all the trailing spaces before you do that, because your last name can be followed by a space, right?
Yeah, if there was spaces here, or even, multiple spaces sometimes like this. Yeah, right off the bat, I would just try to get it all in like one order, situation. But yeah, I'd want to trim the white space of names. And then I would also want to get rid of multiple spaces. So I would do G sub. So multiple strings of spaces. I would replace it with a single space. So that'll give you what you're looking for. Okay. So now the hardest one, I think, is keeping only the middle names. So let's try to figure out a substring solution. So the first idea would be, the first string of characters is going to be the first name, right? So what we can do is just say substring names. Now what I'm going to do is I'm going to start with the space, because that's going to start my substring here, right? So instead of -1, it's going to be +1, because I want to start on the J, not on the space. Oops. And let's just go to the end of the string so we can see what it looks like. Okay, so we got last name, and we got middle name and last name, and then here we just have last name. So this one we always have to be careful if one of them is deviating from the pattern. So let's make this sub 3. Okay, so now we want to remove. Essentially what we're doing now is we're finding the first name again. So we're gonna pretty much just take this code right here, because now that the middle name is now technically the first name. Put it here. Let's change this to sub 3. Let's see what this gives us. This does work, except for one little problem here, right? It gets rid of Julius Randall's name. So if I want to know why, it's because this is a -1. Because this number is bigger than this number, it doesn't really know how to set the string. Like maybe you would go reverse, but in this case, it doesn't know what to do with this negative here. So can we think of a solution of what we should do for this? Does anyone have an idea?
And do like some kind of if it doesn't work, then leave the name as it is.
Right. So we can use if else. So let me just make this a multi-line thing so it's a little bit easier to read. So what we can do is we can say if else this is less than 0, then what we're going to want to do, well, we're going to want to have something, and then otherwise we're just going to want to keep this. Right? We're always going to -1. Or we might not even have to -1, just -1. So the thing that we're going to want to do is we're just going to want to keep the entire string. Oh, sub 3. So now if we check out this, now we got what we want. So what this is saying is, give me sub 3, start at the first position, but the ending position is going to be conditional. And it's going to be conditional on if you can even find a space. If you can't find a space, then you're going to have to just use the entire string. Otherwise, go until you find a space. So this is definitely a much more complicated thing to do, is to pull out the middle of the string, especially when there's not really a pattern like a URL might have. The G-sub solution is a little complicated. I'm just going to copy it here and I'll break it down. So here's the whole solution. So I'm just going to take the middle part and show you what that gives me. So what I'm looking for here is I'm looking for the beginning, the first alphanumeric. So this alphanumeric string, right? That's what this means. But it has to be at the very beginning of the string. So this caret means has to be at the very, very front. The first character has to be an alphanumeric string, followed by a space. So if I just look at this, I'm getting rid of the first names, right? Because it has to begin with an alphanumeric character, go, 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 go until you find a space, delete that whole section. So that's going to be alphanumeric until you find a space, delete this, but it has to start it at it. So it's not going to delete John, right? So the only real difference I have from here to here is this little caret. But then I'm saying, or if you find an alphanumeric character or an alphanumeric string at the end of the names vector, delete that as well. So that's going to delete Alex space and Cardazzi, and then not space Cardazzi. I could also probably do this too. Now it automatically get rid of that extra space. Rather, I did it in 2 steps here. So this one's definitely the most complicated in terms of the substring solution and the G-sub solution.
Do you find sometimes the one's better than the other?
I used to just be like only substring because I thought it was just more intuitive for me to understand. Like these patterns are sometimes a little bit tricky. But I've dealt with a lot of text data for my job market paper, so I've had to get used to this notation.
It seems like a more efficient way to do it, but I agree, like all substring seems to be like, that's the first thing you think about, but then
Yeah,
well, G-sub, it's like shorter.
it's more concise, but you have to do much more. Like substring, I feel like I can do it the first time. So G-sub, I always have to like, okay, let me start with just removing the alphanumeric characters. Then I have to remove the string of alphanumeric characters. Then I have to do it where it's a space after. Like I have to do it in steps and keep proving to myself that I'm building to it. Whereas substring, I feel like I can just kind of nail it on the first try or first 2 tries. Okay, and then this last one, pretty much what I did was I just took a grouping of each one of these results. So if you save each one of these as first name, middle name, last name, you can just use paste 0 and you can have a little dash in between. So you have, this is the last name code. This was the first name code. And then this was, this is saying if there's indeed a middle name, then put a dash. If not, then don't. So that's just how I got this. So I'm not going to go through this too much, but it's pretty much just copying and pasting code into a paste 0. Were there any questions about the string stuff? Okay.
Yeah, I have one question about G-sub. So in that first argument, are you only able to use the or in the string, or could you have an and?
That's a good question. I don't know the answer to it. But it's hard for me to think of what you mean by and. So you're saying, suppose I have like the string Alex, and I want to delete
Mhm.
A and L, or it just,
Mhm.
if I want to delete AL, I'll just type AL. If I want to delete A or L, I'll do it this way. It's hard for me
Okay.
to think of a situation where you would need and, but I don't
Yeah,
actually
that
have an
makes
answer
sense.
for that. Yeah.
I mean, I guess it would just be whatever characters you are including would be the and, like an implicit and, maybe.
Yeah, maybe it's something like you want to delete A or L, but only if they both show up. You don't want to delete just A or just L.
Mhm.
I don't have an answer for that. I'll have to think about it. There's a I posted a link. There's a ton of information right here. So it used to be this link that I had, but it got taken down, I guess, for some reason. So now I have the Wayback Machine version of it saved. So, but it has all sorts of stuff here. Like there's even some conditionals and stuff that I didn't even talk about. You'll have to use this Perl equals true thing. You guys can look at this all, when you need to do it. But I mean, if you, this is like hardcore. There's a ton of stuff here.
Yeah, I'll check that out. Thank you.
All right. So that was the string stuff. Now let's talk about this hacking homework, right? So, oh, I think I actually messed this up. It's supposed to be New York because 4 was too long. But anyway, you have to try to get R to guess the password New York. So this is my password. And you have to write code to break it as quickly as possible, right? So does anybody have any ideas for how they might approach this problem? So let's start thinking about it in terms of like what a hacker might do, right? They're just going to try every single password they can think of, every sort of combination of characters that they can manage.
Write it to try every letter until it gets the first one right, and then do the same for the next one.
Okay.
So something like that.
So what loop would you use for that? A for loop or a while loop?
While.
A while loop, because a for loop you have to run through the entire alphabet, whereas the while loop you could just stop once you get the first letter right or you get the whole thing right.
How can you even test the first letter? If it's password, it either works or doesn't, right?
That's
You
true.
have to get the whole thing.
That's true. You can write it either way, right? If you, however you want to play the game, you can play the game. But yeah,
You can
let's,
still probably do while, but you'd
Yeah.
have to, every time you put in the whole password, right, compared to the.
right. So just to generate all the possible passwords, you could do, so there's a vector called letters. It just gives you all the letters. If you wanted to create a vector that just made all of the possible combinations and then just loop through all of the combinations, you could do this. Or you can write a nested loop where you gotta also go through all the combinations. So the example I came up with here was I created password and I started the timer and I said, I'm gonna set my success equal to 0. And then once I hit success, once I guess the password correctly, then my loops can stop. And then my counter is gonna be 1 because I'm gonna have to go through 26 iterations, right? So it's gonna enter this saying, while success equals 0. So we're already off to a good start, right? It's gonna enter this loop. And it's gonna say letter 1 is gonna be letters of counter 1. So counter 1 is set to 1, so this is gonna be A. And then counter 2, I'm gonna set as also 1. Then it's gonna enter this, or it's gonna check if this is right. And it's gonna say, does success equal 0? That's right. Does counter 2, is it less than 27? Yes, it is. So we're gonna jump into this one. So now I have L1 is equal to A, and L2 is now also going to be equal to A, right? Because I have counter 2 is equal to 1. So then what I'm going to do is I'm going to paste 0, L1, and L2, and I'm going to check if it's equal to New York. I should have put P word here, but I didn't. If that's true, then success is going to be equal to 1. I won't come here. I'll end this while loop, and I'll say, is success equal to 0? If it's equal to New York, it won't be anymore. It'll say 1, and it'll break out of this loop. It'll increment this counter by 1, and it'll ask if success is equal to 0 again. And again, it isn't because we set it equal to 1. So it's just going to go until it can guess the password right. It's going to keep iterating. The second it's going to start on A, iterate through all the letters, go to B, iterate through all the letters, C, iterate through all the letters. And it did it really quickly, 0.03 seconds. So if you build this out, you can see how you can just kind of start to really nest these loops over and over and over again. So you're not really gonna have to build a password cracker, but I wanted you guys to start thinking about how to use a while loop maybe. Any questions, concerns, objections? All right.
So can someone use this code to find out my passwords on certain websites?
I guess they could, but a lot of times the password will like stop you after like 8 tries if you get it wrong. And that's why you want long passwords with different characters and numbers and stuff like that. So it's harder to guess. There's more iterations to run through.
I'm glad I asked. I'll change my password.
Yeah, everyone should have long passwords that have a lot of different variety in them. All right, so this last one. This was a homework that I got in when I was in undergrad. I took a Comp Sci 1 class. I thought it was so interesting. I really enjoyed it. So I always ask people to do this one too. I think it's a really clever way to think about how to use loops. Did anybody come up with a solution for this? Did anyone get the pyramid to run? It's really hard. It took me like a few hours when I was an undergrad trying to figure it out. Okay. So let's just try to build it with the original function call, right? So the original call was pyramid, number of character, or the character was A, and the size was 5. So the character is going to be A, and the size is going to be 5. So we're hard coding this for now. So and then putting into a function should be relatively easy because you're just making it a little bit more general. But anyway, so the first thing to do, you can do this in either 1 or 2 loops. I elected for 2 loops, but you can do it easily in 1. So the way to do this first one is let's just go from I in 1 to 5. And what we want to do is on the first round through the loop, we want just 1A. So we just want to like print A. But on the second time, we want to do it twice, right? So we want to repeat A 2 times, then 3 times, then 4 times, right? So we want to repeat it I times. So if I run this loop, we've already kind of have a start here. Now this is generating different individual A's. I have them all in the same one. What I did is I just did paste. And then there's another argument. I don't know if I touched on it, but it's called collapse. And you can take a vector of characters and just smush it together into one character. And then if you do collapse equals nothing, it'll just squish it all together. So if I run this, you'll see it'll be like that. Now I can write a second for loop from 4 to 1. So going in the reverse direction and just doing the same exact thing. Now you can do this in 2 steps. So you would just do 2 times. You have to go around 9 times. And then if it's equal, if it's less than or equal to 5, you do this one. Otherwise you do, you know, subtract the number of times you repeat the vector. So this is kind of pretty much the skeleton of how you would do it. In order to put into a function, instead of a, you and 5 and 4, you would just put the character here, and then size for 5 and 1 minus 5, or size minus 1. Make sense? All right. So hopefully in the future, you guys can kind of go back to this and check it out. And practice loops and stuff like that. Because this is I really like, you know, don't get discouraged if this is like a lot, because this is pretty, it starts to get pretty advanced pretty quickly. But now we'll talk about web scraping. So I'm going to stop recording and then I'll start a new recording.